uh, will be something that is like you guys can see my screen, right? The documentation I have shared.
Yes, sir, we can see.
Okay, great. So the problem is with normal camera, you will see the same thing that you will see within your naked eye, unless you have applied a filter or something like that that change the behavior of the camera. But otherwise, it's going to be the same thing. What in augmented reality does is it will add more features, show more details based on your surrounding. Okay, so for example, in AR, AR video or AR space, you will see something that is rendered out in the natural environment or natural environment that you will be living on, and it can enhance your surrounding that you will see through your phone. Okay, so there were like few examples maybe you guys have seen. So there are filters on your mobile phones, like when you open your camera, most of the time these days you will find filters that enhance your looks. Okay, there are some filters that you can apply a beard on top of your face. Okay, and when you move your face, the beard also moves again. It's not something still. It moves with you. So that is one example of augmented reality. And there are some scenarios where if you point out a certain space or a certain area, we can render some animal, some feature, or maybe something out of a game or something like sorry, something that you want to render out in a natural environment. You can do that. So I have I can show you some examples in video format that will make more sense. I think most of you guys have seen these kind of things in reality. ARCore. So there are examples that you can see in the real world. In the real world, sometimes you will see some examples within new games. So I think you guys probably have heard about the game called what was it called? Pokemon Go. Anyone have heard about Pokemon Go? Think it was like a little bit of hyped on certain days. So it has a few ups and downs. I mean, obviously, there are like things like if you go to a open area, then you will see some dragons or some frictional characters appear on that ground. So that kind of rendering happens using the AR technology. So I'm trying to find a good example. There was one I had it in here. Let's see it anyhow. ARCore. Where is the sure. No, I don't think I have it, but let's move on. We will see some examples while we are at it. So there are some nice additions to the AR community, like say for example, you want to educate your children using AR technology, where you can use your phone. Okay, they feel the natural surrounding. They are not wearing any headset or something like that. They will they will see the natural environment, but when they're looking through the phone, it will be a completely different surrounding that they will see. So it's easy to educate them, and it is more interactive. um, so we'll look into the basics of AR related technologies. So these are like the three pillars, so three concepts behind the AR application, or at least in general AR. So first thing is that we need to know is the motion tracking system. Okay, so so we'll be using something called ARCore, okay, a library that is provided by Google to develop Android applications with AR capabilities. Okay, so if there are like fundamental things that you need to know when you are developing such a application. So you don't have to start from scratch. ARCore is there to help. um, ARCO will give you fundamentals, things like motion tracking, environment understanding, and light estimation. That kind of details, that kind of information is provided to you. Those kind of mechanisms, you don't have to write it from scratch. ARCO will give you the support, the extensions that you can like reuse them and build your own imagination or your own AR application. So ARCore is from Google, and the rival for iOS, we have something called ARKit. Okay, the ARKit is one of the projects that supports augmented reality within iOS or iPhones. So the two kits that we are having, it's they, even though they achieve the same functionality, augmented reality throughout these libraries, but the functions of each other and the libraries and the ecosystem are completely different on each other. And if you are interested in AR, and if you want to go if you want to go more in details, it will be not something that a hybrid platform like Flutter or React Native can help. Okay, it's really hard to come up with these kind of correlation, but I have seen some libraries out there which like kind of help, but they are not good as the native counterparts of the applications. So we should be when we are developing AR application, if there is a requirement when you are developing your next mobile application, AR is involved within one of the projects. Definitely, my recommendation is go with the native implementation, ARCore for Android, ARKit for Apple, because the native performance cannot be achieved from other hybrid frameworks or hybrid libraries. So that's something to keep in mind. And one other thing that I would like to highlight, that when you're using AR related technologies, uh, the phone itself, the hardware itself, the operating itself, it matters the most. Okay, so there are only few phones out there compared to the number of models within the market. There are only few subset of phones which support AR, because ARCore is not supported on each and every smartphone that you will find out there. Okay, even your phone is smart, there are certain limitations, there are certain calculations that we do. Like, for example, if ARCore need to do some motion tracking, the CPU or the memory that within your smartphone is it should be able to handle that kind of what do you call calculations, memory management. Otherwise, what will happen? Your phone, your app will crash definitely. To avoid that, your phone or your model devices should be listed out. So I can give you a brief uh, link. Okay, you can show it in here. So if you go to this link, you will find all the devices which are currently supported, and what are the things, what are the phones as from manufacturer and models, what are the phones which are supported, which are not. Okay, some supported. Uh, some features are partially supported, some features are fully supported. So when you are developing an AR application, make sure you will be targeting one of these phones, otherwise it will not work as expected. Okay, so if you are having a good high-end feature phone, a high-end phone, you will be definitely in good hands. But there are some models which will not support AR. So the hardware and the memory capabilities, hardware and software capabilities are not matched. So make sure when you are developing an AR application, uh, take a phone, an Android model that is supported ARCore. Okay, so first thing that I would like to talk is this concept called motion tracking. So AR can detect and visual distinct features in the real world to understand its position in space. Okay, motion tracking in the sense. Uh, so if you take something like a small video, and within that video, a person might be walking. Okay, anyone can walk by. The background remains still, but the person will start from left end to right, and he or she will get disappear. So during this time, we can assume that background will remain still, but the person walking from left to right is changing its course on different frames. Okay, so when we are using motion tracking, what happens is we can detect the person moving from left to right. Okay, that that capability, that segment, we call this background segmentation, is provided to us by the ARCore libraries. So why this is so important? So if you guys have seen face filters, okay, where you can apply some sort of hat or some sort of a beard or maybe some set of makeups. You can change your eye colors, whatever you do. So when you are doing that, you are trying to change your face, right? You're gonna tilt a little bit to left, tilt a little bit right, and what will happen is it will detect that, it has to detect that, and it need to differentiate the background from your face. Okay, so motion capturing involves, okay, removing unwanted area. So in a video where my face is visible, I need to remove anything that is not moving. That is not moving in the sense it's gonna be the background. Okay. Then we need to detect the face. The second phrase is we need to detect the face. Okay. Okay. There is the first filtration is, okay, we are removing background, that eliminate unwanted areas, unwanted information from our algorithm. So we can focus only on the motion section. Okay, in that motion section, we need to find the face itself. Otherwise, it won't work as we expect. So we have to make sure our face is visible, and when and only when our face is visible, we can see like um, uh, so when our face is detected, like okay, the algorithm can detect our eyes, our nose, and our mouth. They can track, okay, this is the face, it is moving. Now we can specifically target one of our facial features, like they can only focus on our eyes, they can focus on our nose. Depending on the motion, we can track any movement throughout the application. So writing an algorithm to detect motion tracking, it will take a long time. So, but for lucky for us, the ARCore library sorry, itself provide these capabilities. So we don't have to search everything or use it from scratch. We can just use the ARCore features and we can do the motion tracking. So motion tracking is provided to us, and I have explained why motion tracker is important in terms of AR applications. It's because we need to figure out what is moving and what is not, and based on that we can apply our augmented realities. Okay, the next thing is environmental understanding. When we are creating AR application, most of the time we will be as I mentioned, we will be enhancing what we are seeing right now. So let me show you an example like this. So if you guys can see, it's look like a normal room where you will find um, basic things like chairs, walls, plants, and everything, and there's a floor. So within your flow, you will find these Android figures, okay, which clearly they are not part of this environment, but we have placed using augmented reality. How can we be sure these are augmented? I mean, it's from looks of it, these colors, these shadows are not quite realistic, so we can assume these things are not from within this room. So we can conclude that okay, these are augmented items, augmented objects. So you can see that there is the flow, and there's these figures that we have placed. But all the surprise is going, okay, they have they have placed these figures right around the floor. Okay, it makes more sense these figures to be represented in the floor rather than it representing on top of this plant. Okay, on top of this plant, yes, you can put something in here, or you can put some figure in a long line with this room border or room wall border, but it is not realistic. Why? Even though we can place it somewhere else, we have placed an object which is not realistic, which does not make any sense for us if you think about the position. So what ARCore does is they try to understand the context of your picture, or context what you are seeing in here. So you can see that there is a flow. Okay, the flow is detected, the flow is understood by the ARCore itself. So we know, okay, when we want to place something, when we want to show something, the environment itself is understood, and we are placing on the floor only. Okay, we can do for horizontal and vertical as well. But depending on your requirement, you can say, okay, ARCore detect an environment features which is a horizontal flow. Okay. So for example, if you want to place something on a wall, okay, like a picture or something like that, it does not make sense to put it in the floor. Okay, you have to hang it around the wall or something like that more makes sense. So we can say ARCO, hey, just scan for a vertical space, and it will only search for vertical space, and it will not allow anything to be sticking around the um, uh, sticking around in the horizontal space. So make sure these things are like really good, or really working well. Otherwise, what we have to do is we have to train a lot of things like this is a flow, this is a plant, this is a vertical wall. That kind of environmental understanding, it's quite complex in terms of uh, it quite complex that we can't really understand the things. So lucky for us, ARCore is doing those kind of understanding things uh, within the library itself. So we so we don't have to worry about environmental understanding. Okay, so environment understanding is something very important when you're trying to place something in the real world. Okay, you can't randomly place anything, and you can't place some unrealistic places. So we have to make sure uh, uh, the environment that we are trying to put is something understandable, or something makes sense. Okay, and the next thing is the light estimation. Okay, so as you can see, I'm not sure whether this photo is like really realistic or something like that, but when we are placing something in the augmented reality, we have to make sure these little green things, it make more sense. These figures are in this color, like light green. But say for example, we will be in a little bit more darker environment. I'm not talking about a complete pitch black scenario, but at least a little bit of darkness is built into this, or maybe the light source where it emits the lights is somewhere on the corner, and it make more sense. The reflection of that, the brightness of that, will be adaptive to the figures that you will see in here as well. For example, if we are in a little bit of a dim room, it would make more sense, these figures that we see in AR, those to be little bit not that bright color, but at least match the lighting of the room. Okay, so light estimation, that's kind of in things. And if we can see a light bulb is if you can estimate where the light source is, then the reflection on these things, you guys can see that there is like the bright spot on these figures. They have the same, even though these things are facing different directions, the bright spot, the light estimation is always on the um, front side of your application. That in that scenario, we can make sure this application is this light that we see in the AR application, AR app, is correctly reflected on the figures or 3D models that we see in here. So as mentioned earlier, light estimation, understanding of the colors, the brightness, and the source of the object is uh, estimated for us. So it will make more realistic to the application itself. Otherwise, as I mentioned earlier, even though the uh, placement is good, but if you don't understand the lightings, then it is also a little bit unrealistic. So to make more things realistic, we have to understand the light, we have to understand the environment, and we need to track the basic movements. So like these are the most fundamental things that you will need in order to develop an AR application. So these things are provided within ARCore. So yeah, you can go ahead and think these are covered for some extension within your application. So you don't have to worry about doing these things over and over again. Okay, and before we start on any AR application, there are some terms that we need to know. Okay, without these terms, we will be not able to understand the concepts of ARCore. So we need to at least have these four concepts in our mind in order to develop a good AR application. So first thing is that we will be seeing is something called feature points. Okay, so uh, feature points, in the sense, it is something visually distinct features which we will see, which can be detected from your phone. Okay, so each and every so most of the time when we are doing an AR application, it's not going to be one single image. Okay, it's not going to be a static image where you will be seeing. You will be seeing something like you will be seeing something like that in a moving environment. Okay, so when we are moving, the camera will detect visually this distinct features. For example, let me go to the example image that we are seeing in here. So you can see that the visually distinct positions, like this wall, this the wall is distinct from this adapter or from this little device on here, and the wall is divided from the device that we will see in here. And you can see also there is this vase, and the vase is different from the background it is surfing, and it is little bit it is different than the flow it is in. So these are this I'm not sure you guys can see this little dot that you will see. Those are unique visually distinct points within your application. So we have to when we are talking about feature points, we are talking about, okay, visually distinct position within our camera that we can see. Okay, ARCore, when you're using ARCore, we are talking mainly on ARCore. Combination of sensors figuring out your location, space, and estimate your pose. Okay, so not by looking at the camera itself, the distinct between the colors and distinct between some of the um, main differentiation between the colors and the thickness or the spread area. There are some other techniques that we can detect feature points. For example, the distance between these two, between you and the wall. There are some other sensors, not in every phone that you will find, but where you can detect the distance between two or more. There can be gyroscope, which you can say what is the tilt that you are in. So likewise, based on various and most um, techniques, like if you use two cameras, okay, most of the time nowadays we have multiple cameras within our application. Using two cameras, one with wide angle, one is with the normal angle. uh, since these two cameras can be combined into sensor, uh, these two cameras can be combined in order to take a measurement out of your photo, okay, especially with distance and short distance at least. We can take extra input to detect feature points. Okay, it's not only about color but about other distinguishable visual features that we will be using in order to detect feature points within our AR application. Okay. Uh, Okay, the next thing that we want to talk about is the concept called pose. Okay, so pose as the position or the orientation of the camera. So, for example, um, four objects with different poses. Okay, you guys can see that the two eyes, at least I'm not sure whether you guys can see it directly. The two eyes in this Android figure, uh, two are looking at the picture itself, but these two are looking at on opposite directions. Okay, so if I move my camera near to this Android figure, what should happen? The angle that we am looking is like something that I should be seeing their faces, and they are looking in front. I'm looking in front of them. So while I am looking at these guys, these two figures are in what do you call, in opposite direction. These two figures are facing backwards to me. Okay, so these features are not showing. These two features does not show the front. That makes sense in real life as well. If you are talking to somebody, the person who is talking with you, you can have eye contact. But if somebody is opposing your view, or you can't see, they are turning back on you, you can't see their faces. But as soon as you move around this, okay, you were here, now you are moving around from here to here. Now the camera angle changes. The way you look at these figures have changed. So when we are changing that, now earlier I was here, now I am at here, now I should be seeing the face-to-face interaction with this figure, but maybe a tilt one at least for this figure, but not the full view. As soon as I am moving in here, the earlier on the figures that I have seen in here are now facing backwards to me. Okay, so whenever we are moving along the camera, the pose, it gives us a realistic look on how we perceive the object that we have placed. Okay, so when you are moving around, you are looking from up, you are looking from down. The pose is giving us an angle to look at the objects that we have placed. Okay, so pose is one of the main features that we should be seeing within the application. So you guys can see it as well. Yes, so the perspective that matters a lot, because in a AR application we'll be placing something, we'll be enhancing our visuality. So if you are looking at from a different angle, if you are looking at a different perspective, the view should change as accordingly. So it makes sense to have such a feature. the pose of your application is something that is very crucial in here. Okay. Right. Next thing that we'll be looking is something called plane. Okay. So the plane is what as you might have guessed, plane is where we are gonna be we will be placing our figures. We call these things models. So the surface that we'll be looking at, it can be a table, it can be a floor, it can be a desk, or anything that detects a surface, we call that as a plane. So in here, this room floor, we can consider as our plane. So the plane is, this is a horizontal plane. So it has detected it really well, and we can see this the planes really clearly, and we can place anything within this plane. So basically, plane is the surface which has been detected by ARCore. Okay, not only ARCore, but anything, any like ARKit or any other framework, the plane should be where it's realistically match the flooring area. Now, if you take a closer look, it is not 100% correct, okay, but you can see that this area in here, it is not detected as a plane, but some area within the wall itself, they have detected as a surface. Okay, so these kind of things are really simplistic, that can happen. I mean, obviously it's need a lot more training and a lot more things that we will need more improvements. But then again, it's something that can happen, and it will be something normal. Okay, so plane detection, we should know what is the plane, where it's going to be rendered out and everything. But for now, plane detection or plane, you should know what do you mean by a plane. So next thing is anchors. Okay, anchors play a key role. So anchor is the virtual object to be placed to an anchor. Okay, so that means when you're placing something in here, okay, when you're placing something in here, and if you move along this line, this should not move. Okay, if I place this model or this figure, and if I move in this direction, this should not be static on this location. I mean, not in this screen. It should not be something like that. It should follow up. It should it should not follow up, but it should remain that place. And when we have come back, it should be in here. Okay, so we are calling putting this in an anchor point. Okay, so anchor point is like okay, this area is, let's say, office room, and we can name this area like let's say the working area. Okay, in a place, in a augmented reality screen, when they are detecting everything, an anchor is placed in the working area, and when we are moving to this AC area, this area is marked as the working area. So the anchor that we place, the figure that we have placed in here, will not appear in here. Okay, so anchoring happens within the environment that it knows. Okay, and when you put it in here, it should not move here and there, and it is not like something that statically should be moving or changing. So make sure this anchor is something that you understand with the placement within the plane. Okay, within the plane, the anchor is placed in here, and it will be understood by everything. So we will see a real life example, so you guys can understand at least the concepts, and we'll see more in action. Next thing I would like to talk about some of the implications of the figures or some examples that you will see. Okay, so yeah, let me get different kind of augmented realities first, and we will move on. So for example, as we talked about earlier on, these are the augmented reality applications that we can work on. We can have face filters, some cool effects, maybe based on the detection of the face. There can be different actions. I mean, it is these things. I mean, you guys probably have seen use cases like this. Okay, you can wear different costumes, whatever things you like. The technology behind this, the face mesh and everything is fully supported by ARCore. So you guys just basically have to go in and do the coding. So you don't have to work on so many things. So everything that you need to make 3D mask, 3D models are already in here. Okay, there are a lot of examples out there, developer guides that you will see how to make these kind of masks. A lot of things are in code, and sometimes even I don't understand the codes. It's a little bit confusing, but time to time, when you are good at it, you will get the hang around it. Okay, that is one use case using the face. And the next thing is augmented images. So this is something that you might have seen during the last presidential campaign, perhaps. Our former president have used some sort of AR mechanisms to like do the campaigning stuff. So you have to like download an app. When you point after you download it, and when you point your phone to a specific news article, the president will pop up and say his vision and everything. By the way, went really bad vision. Aparad Salli for the AR, but at least we have seen it. That is something cool we can learn. So this is one of the examples. I'm not sure. Okay, this might take a little bit time to load. So idea behind this, the AR is we will be taking some certain feature, some certain thing in our application, and we will scan it first. So you guys can see there is this wall painting sort of thing. Okay, it's something unique that you can easily identify. It contains some bricks kind of architecture, and it is held on the wall. And when you develop the AR application, you have to like have a look around it. Now, obviously, you guys have seen there is this black border appearing out of nowhere after you scan it, and the AR kicks in. Now you guys can see the image was in the wall is replaced with something in the real world, something that is out of the real world. And you guys can obviously see when we are looking at in different angles, different directions, obviously the pose of the image change. Now you can see that's a direct replacement of that image. You can't see that image no more, but augmented image is placed on top of it, and you will be able to see a different world, um, different uh, part of this application in a completely different way. Okay, but remember, when we are trying this, we are not creating a virtual world, but we are simply augmenting out, we are simply enhancing the view that we currently have with something more creative, something more attractive. Okay, so it make us to give more in-depth uh, in-depth um, in-depth about the surroundings. Maybe we can have extra things, and so on and so forth. So it will be really easy to do such thing. Okay, there are a little bit of um, things that we need to consider when we are replacing the image. Okay, so this kind of image contains repetitive geometric features. This kind of image to detect is considered as very bad one. Okay, and there are so many similarities that you will find when you're looking at this image. The windows, they look so much similar, the points, the colors, and everything is somewhat similar. So if you're trying to replace this kind of figure with what we have seen earlier on, it will probably fail. But if you do look something like this, it's really unique, the picture of the earth. You can see there is white sections on here and dark section on here, a lot of patterns that we can uniquely identify. So something like this will make a good candidate to replace an image. Okay, you will find a lot of these features built into the ARCore system. Sometimes you will find examples on different places, like Unity. Okay, if you guys know Unity, Unity is a game engine. Unreal is also a game engine. So you will find these augmented features on not only on Android, but also in other uh, gaming. Sorry, did I stop sharing? I'm not sure. Stop share. Let me share it again. Google Chrome. Which one is that? I can see correct one. This one, right next to it. A lot of views opened in here. Okay. So these things pretty much now built into game engines as well. That's because a lot of these things are more CPU intensive work, which is correlated to something like what you will see in something that you will see in a game engine. Okay, the game engine can definitely handle these kind of huge CPU intensive tasks and so on and so forth. So these are like really examples on what we can do. This is like not limited to this. And let me check the um, maybe you guys have seen, even though it is not something that you will see in a phone or something like that, but there are special gears that is also used to do augmented reality as well. One of the most popular one is called the Hololens. Okay, maybe you guys have seen it. Let me check. I can get a demonstration.
Look professional with GoDaddy.
First of all,
Let's say there are 2 new emails in your inbox.
Today, I get to show you. This is the device that I was talking about, the HoloLens. So it is not like a surface mounted smartphone or something like that. It's also something like a headset, but it is not completely binding us and showing us something out of the ordinary, but it is showing us the real world, but it has some displays around it, and it will show us more than what we see in the environment. Let's take a look on this, and we will try to see it.
Something very special.
So this is the HoloLens, okay, from Microsoft.
Wanted to create something
and they will see how it will look like if you are wearing a HoloLens. Okay, so
now,
if you,
as Alex mentioned, HoloLens 2 is very comfortable. It fits just like a hat.
okay,
And the
so
only thing that's even more
this is how it's really gonna be seeing for this person.
effortless.
It is not rendered or not is something like
Windows
that.
Hello and our authentication. HoloLens
These
2 is
things
actually
are
signing me in.
really seen as the
Now,
person is
not only does
narrating.
HoloLens 2 recognize me,
Okay.
it also recognizes my hands. Look at this. Fully articulated hand tracking. And as I move my hands around, the HoloLens 2 is actually calibrating to my unique hand size.
Okay, these are not like what you call
not only does
3D
HoloLens 2 recognize
embedded
me on my
ones.
hand,
These are like
it also
real
recognizes-
things. Okay, so they understand the
Also,
surrounding
mixed
and
reality.
change.
This is the place where I have all the apps and content that I
Okay.
use every day. Let's check some of them out.
So if you have
Now,
something like
I've
this,
seen
this
many
is
people
what she will see,
first
but
thing
from
people
our
do
angle. Okay, so the pose is consistent, but if she is looking at it, she will be having the opposite pose.
put on the
What
device,
we will
reach out their
see,
hand, try and touch the hologram.
and you can see that
And now
these
hand.
interactions are
Look at the way the
very
hologram
much
is responding to
visible.
my hand, almost inviting me to touch it. And in fact, I can just grab this corner to resize it. Or I can rotate it. Or move it. That's right.
Okay.
We are touching hologram. This is an app I've got called Spatial. Let me just put it right there. I've got another app here called Euphoria View. Now it's a little big, so let me put my voice. It actually followed me in. Now,
So
this
you guys
actually
can
be
see
many
these
sampling, the audio.
realistic things that we can do. Okay,
Sure.
I'm not gonna go one by one, but
by combining our hands.
the view that they are having is the same view that this
earlier in the cycle. For instance, guys, take a look at this wheel clearance here.
post that we be having. Okay, so nice to have have a look around those things as well. And it was like 2019 this was released. Now it's even more advanced, advanced in reality and in AR world. But unfortunately, the technology I think now is, as I have seen, rather than going to general public, I have seen a lot of articles that the HoloLens is used in military operations. So good and bad in two ways. So like when you're at war, you can get more tactical advantages if you are wearing something like this. Okay, so yeah, I'm not saying that it is a bad product or something like that, but people can use in different level. This can be a life-changing technology. Say, for example, AR can be used in so many use cases. Like, for example, let's say I have a broken pipe in my house. Okay, I can wear my headset and go near the pipes, and a technician can connect to my AR headset, and they can instruct me. Okay, they can point out the places that I want to do, I want to touch, I want to collaborate, that kind of thing they can do. Okay, without a hassle. I don't have to see it through a phone or manual instruction. They can highlight. Okay, now you have to change this parameter. They change this. So imagination is limitless, where when you can point something out of the ordinary, out of the reality that you see through a lens. There can be so many things, so many bad things as well. But you guys can know the good and bad effects. That's up to us to whether use this in a good way or a bad way. But anyhow, back to the topic. Anyhow, when you are using, when you're looking at AR project, most probably you guys should know about these things. Okay, what is a feature point, what is a pose, what is a plane, and what is an anchor point. Okay, we will go through an example and see each and every one, at least this one, and you guys can try it out yourself, even with your emulator. Okay, emulator will be providing us since it is built in our within our machine itself. We can't actually interact with the real world, but within the emulator itself, it will create a dummy environment for us, so we can play around. Okay, so it's containing a living room condition, so where we can understand what it's what's the algorithm should behave like, or we can just test around the AR features. And one more thing, if you guys can get the lighting. Okay, we talked about in earlier on. So you guys can see within this application even itself, the kitty cat on here have more lighting, but the kitty cat on the shadow, they have a little bit of dark tone to them. So that's how lighting works. You can find more examples in here. I mean, it is more realistic when you're placing something. It shine on the data source itself. Sorry, the light source itself. Otherwise, it will not make more sense. So if you put something like this, it does not make sense. But you guys can see the shadow and lighting and everything. This is more realistic. Okay, these images are more realistic because the light is coming from this side and only this side is shining and this side is not shining at all. So that's the expected behavior of things that you will see. So the realistic of this application, this image is improved. And you can see the shadow of each and every one. You can see that if light is coming from here, the shadow is casting on the other way, and so on and so forth. Okay, and when you're looking at this from behind, you can see the shadow is in here, and obviously this side should be much darker. But if you look it from the front side, where the shadow is casting on the other side, it makes more sense to have a little bit lighter version. Okay, that is the real world scenario on this. And if you have a side view where you can see the shadow from one side, and you can see the light side and the dark side. Okay, this is called light estimation. This is also happening out of the box from the ARCore itself. Okay, so we will try to get more into this, and there are a lot of lot of theories behind it, but it's easy to show you guys in real life. But I'm not sure I'm gonna be explaining the code behind it. It's really complex, complicated things are going on. And since the application usage of AR application is very rare compared to a typical MVVM or some data presentation application, I'm not gonna go through each and every line of code and try to understand, but we'll get the basics around it, and you can always go to the source and get an idea on that. Okay, I think it's gonna be for today, because I'm having another meeting a few times. So any questions up until this, guys? Okay, I hope not. So go through the slides, take a good idea on these things, because these things are really important in terms of, memorizing and have a look around it. And yeah, that's pretty much it from my side, and we'll see you next week. If you guys have any questions, post me or ask in the group. We will try to answer those things. Okay. All right.